is about maximum, minimum, and saddle points of function of two variables. Here is the function. We'll have to find its maximum, minima, whatever points we have. So let's call GeoGebra. As you can see, I have previous exercise here. So instead of deleting from the bottom, I delete the top. That deletes everything that depends on the function, and I delete this vector. Input my new function, f of x comma y equals x to the fourth right arrow plus y squared right arrow minus 4xy plus 1. We have to find, first of all, the critical points where the first derivative has 0, for which I have to compute the first derivative. So let's see. Derivative of f for x once. Derivative of f y once. Now, before continuing, let me compute the rest of the derivative. We need the second derivative from x twice. So we put here derivative fx twice, and the second derivative of f with respect to y twice. But we also need the mixed derivative, once with respect to x and once with respect to y. So the best way to compute is, this is once with respect to x, so we'll compute the derivative of that, derivative of a with respect to y once. There it goes. So this is the partial with respect to x, with respect to y, twice x, twice y, and once x, once y. Okay, so let's find the critical points where these first two derivatives are 0. Use the solve parentheses, curly bracket, a of x comma y equals to 0, comma b of x comma y equals to 0. So we have three critical points, 0, 0, 2, root 2, 2, root 2, minus root 2, minus 2, root 2. Now let's compute the Hessian on each of these. So here is the Hessian for the 0, 0. Let's call it Hessian 1, Hessian 0, 0. Or let's, whatever, P1, the first point, is equals to, this is a matrix, so we open the matrix. First goes this, the second derivative with respect to x at the 0, 0, comma, and then on the first row goes the mix with respect to x and y, which is the e. So e of 0, comma 0. We close this, we close the curly bracket at the first row. On the second row goes the mix, 0, comma 0, comma 0. And then it goes the second derivative with respect to y twice, which is this. So d of 0, comma 0. And that's the Hessian at the first point. What do we see here? We see the determinant of this Hessian is negative, so the first point, P1, is a saddle. Or we write here, saddle point equals to P1. Okay, doesn't matter. It's no. Saddle point equals to 0, 0. That's the saddle point. Let's compute for root 2 and 2 root 2. There are two ways to do this. Let me call the keyboard, maybe easier for you. But before anything else, as we have to do this, let's copy this guy here, duplicate, so it comes here, so we can edit the entries. This is 2, so the 2 goes here, and here is 2 root 2. 2 and now multiply root 2. Then again here is 2, and then we move here 2 root 2, and here we have 2 and 2 root 2, and here again 2, and here 2 root 2. Let me close the keyboard, I don't need any more. Enter. So here it is. What do we have? The determinant is positive and the first term is positive, so this is maximum. Maximum 1 equals to this point, 2, and okay, we have to enter again. Oh, I have deleted by mistake, so let me call the keyword first, and then maximum 1, maximum Okay, first maximum is 2 and 2 root 2. That's our first maximum. Now, it's given here the value of 2 root 2, but don't worry about that. Just to make clear at this point. For the second one, which is this, I'm going to copy this matrix here. So I duplicate it. And I have that one is minus root 2 minus 2 root 2. So it's the negative of this one. So let me put it here also. I'll put here the minus, and then I'll put here minus, minus everywhere. That's it. Again, it's the same metric, so it will be another maximum. I cannot call it maximum because the maximum is defined here, so I call maximum 2 equals which point? It's minus 2, comma, minus 2, and now we call the keyword to enter root 2, close the keyword because it looks very ugly. That's it. We have a saddle point, first maximum, second maximum, and that's all about this exercise.